Hello Math 2 and welcome to week 14, aka the last week of the class. So this week is going to be just a review, basically problems from throughout the semester. The homework will also be review, and I'm not going to make a separate video for that because they are basically just homework problems that you've done in the past. The computer is just going to change the numbers for the My Math Lab homework. And if you look at the final problem set, basically, I'm going to be doing problems just like that. For example, number 1, use the definition of the derivative to find out what's the derivative when you insert a 2. So this is going to be the function. This is going to be f of 2. This is going to say the limit as x approaches 2. And then we need to do some algebra. So take the limit as x approaches 2. And first of all, this part is saying just write down the function x squared plus 3x and then minus, and now substitute a 2 into the function. So that's going to be 2 squared plus 3 times 2. And then on the bottom, we just have x minus a. And then a is a 2. I should have put a 2 right there. All right, and then we need to simplify on the top. So this is going to be 2 squared, which is 4. This is going to be 6, so that means this is a 10. So basically we have x squared plus 3x minus 10 is divided by x minus 2. And it's still saying the limit as x approaches 2. And then the numerator can be factored, and not only can the numerator be factored, I know that this x minus 2 is going to have to cancel, so I know that x minus 2 is one of the factors. And then 2 times what will give me a 10? My brain is telling me that's probably a 5. And because this needs to be a negative 10, a negative times a positive will give me a negative 10. So this actually should say x plus 5. And if you check the middle term, this would be a positive 5x. This would be minus 2x, which leaves 3x, which is exactly right. That's good news. And then you guessed it, it's time for the red pen. Cancel, cancel. And now that I've canceled, I can substitute that x is a 2, which means this is going to be 2 plus 5, aka 7. So there's using the definition of the derivative for number 1. From this point on, you don't have to use the definition of the derivative. You can use things like the power rule. So find the equation of the tangent line. So that means I'll need to take the derivative. Also, for the equation of a line, I need to know not only x, but I also need to know y. So I'm going to do that algebra part right here. So if you take an 8 and plug it in for x, it's going to say, what's the cube root of 8? And that is going to be a 2. So that means that the point is actually 8, 2. In case you were wondering what the point is, that's the point. Then for this derivative right here, I'm going to rewrite this as x raised to the 1/3 power. So this means the same thing as cube root. And then do the power rule. So the derivative is going to be, so take a 1/3, put it in front. And then when you subtract 1 from this exponent, it's going to leave behind negative 2/3. And I don't like using negative exponents, so I'm going to change this and say this means there's a 1 on top, there's a 3 on bottom, and there's an x to the 2/3 on the bottom as well. And the next thing to do is plug in this 8, and then that will give us the slope. So the slope equals 1/3 times, and then put an 8 raised to the 2/3. So first I'm going to do this without a calculator. This means take the cube root of 8, which is 2, and then cube that number, which is 4, and then multiply by 3, which is 12. And I can't do that with my left hand. So that means it's going to be 1 over 12. And then if I want to check and see if I did that right, then I could say, what is 1 divided by a 3, and also an 8 is raised to the 2/3. Put that in parentheses. And then also ask the calculator change that to a fraction. And it says, well, you should have gotten a 1 over 12, and I got a 1 over 12. So that's good news. And then we have one more thing to do. So the point is 8, 2, and the slope is 1/12. So now use the point slope formula to find the equation of the line. So y minus the y value of 2 equals 1/12, and then x minus the x value of 8. And now I just need to simplify this. So if you distribute, there's going to be a 1/12 x, and then when you multiply this times this, that's going to be negative 8/12. And an 8 divided by 12, when you reduce that fraction, is going to be 2/3. So this is going to be minus 2/3. And then there's only one last step, and that is to solve for y, just add 2 to both sides. And so my final answer, I hope that box is big enough, y equals, there is a 1/12 x. My goodness, the sun just came out. All right, now the sun's going behind a cloud. That looks better. And now I just need this part. So that's 2 minus 2/3. So 2 minus 2/3, get that as a fraction, that's 4/3. So plus 4/3, and then this one is done. Next. And with these first few, I actually went through the problem set and made up questions that are very similar. So similar to number 3 is, use the first derivative to find out where this function is increasing. So that means not only find y prime, but where is y prime? Positive. That means increasing. And then for the derivative of this one, we get to use the quotient rule. So it's going to say the derivative equals, and start by taking the derivative on the top, which is going to be 2x minus 1. And then you just copy down the e function. Next, the quotient rule goes minus. Now, leave the x squared minus x alone, and take the derivative of e to the x, which is e to the x. And then the last part of the quotient rule is that the denominator gets squared. So it turns out that this has an e, and this has an e, and this has an e, so I can actually cancel 1 e to the x here, 1 e to the x here, and 1 e to the x there. Now the e function is always positive, so basically if you have a fraction and you have a positive divided by positive, the bottom is always positive, so I really just need to find out where the top is positive. So I'm going to put them in order and do the x squared first. So there would be negative x squared, and then this and this would make a positive x. Together with this makes positive 3x. And then the only thing left is a minus 1. And then put that equal to 0. And then that looks like a good time to use the quadratic formula. So that's going to be x equals negative b plus or minus the square root. And then b gets squared minus 4 times the a times the c. and then it's all divided by 2 times the a. And this is going to be 9. 3 negatives in a row is negative, so that means it's 9 minus 4. That means there's a 5 in the square root. Okay, so now use the calculator to get the 2 decimal answers. So I should use parentheses and then say -3 plus the square root of 5, and that gets divided by -2. So one answer is x equals a 0.382. And then redo the same thing except with the minus square root. So just change this to a minus, and then I get a 2.618. And now I want to see where the original function is increasing. So now graph the original function before we did anything to it. Y equals, put parentheses, x squared minus x, parentheses, and then that's divided by e to the x. And then go to the graph. So where is it increasing? That was decreasing. So right in here, it's increasing. So it went down, and then it went up over this little tiny hill. So that's the increasing part. And then after that, it goes down. So let me zoom in a little bit. So the answers that I got are pretty small. So I can make this go from, let's say, -1 and then 2.6. So I want to go past 2.6. I'll go to 5. And there were no negative values, so I don't need that. And that little hill was not very big, so 10 is too big. I'm going to guess 4. And then let's see if we can see it. So it looks like I cut it off a little bit too much. So maybe this should go from -1, which is what I meant to type last time. Maybe this should be -1. Then maybe we can see it better. Okay, now I can see it better. So where is it increasing? So that's from this point right here until the top of this hill. So this should be the smaller number. Trace 0.382. Yep. And then it's going to go up. So this is the increasing part until it gets to the 2.618. So it's actually between these two numbers where it's increasing. So then I can just label my final answer for increasing. It's in between the 0.382 and the 2.618. All right, then on to the next one, something about the second derivative. So number 4. Okay, it's getting sunny again. Okay, now that's a little bit too dark. All right, there we go. So use the second derivative to determine where the function is concave down. So essentially, concave down looks like this. It also means that the second derivative is negative. So we need the second derivative. But first things first, the first derivative. So just use the power rule on each one of these. It's going to be 3x squared. And then 2 times 11 will be 22x. The derivative of 8x is just 8. And the derivative of a -7, sorry, I need to adjust again. I don't have a professional studio, and there's a big window next to me. And the sun keeps going in and out of the clouds. Sorry about that. So the derivative of -7 is 0. And the derivative of the 8x gives us the 8. Then onto the second derivative. So this is going to be 6x minus 22. And then set that equal to 0. And then we'll solve for x. So here I could just add 22 to both sides. and then divide by 6. And then I'm going to go ahead and get the decimal for that, as well as I'm going to check it on the calculator at the same time. So I'll graph the original function. X is cubed minus 11x squared plus 8x minus 7. And then zoom standard. And hopefully I'll be able to see the whole graph, which I cannot. So the graph is actually down here. I need to have more negative y values. So how about if I guess negative 50? And then, oh, I could almost see the whole thing. So I can see that it went down here and then came back up. So I could keep the guessing game, or I could just trace and say, how far is it going down? So now it's down at negative 120. And then it went down to negative 140 and it's coming back. So if I change the window and have it go past negative 140, so something like negative 150, then I should be able to see. All right, and by looking at the graph, it's right about here that this is concave down and then this is concave up. So right about where my pen is, that should be this x value. So trace and put 22 divided by 6. Yep, that's pretty much where my pen was. And it's the left side that's concave down. So for concave down, the left side would be from negative infinity until this number, which I'll go ahead and put the decimal, is 3.667. So that's the concave down. All right, then some related rates. Suppose that you have this function and the derivative with respect to time is 4. So that means in the up and down direction, this thing is going up at a rate of 4 meters per second, or whatever the units are. And then find, this is supposed to be an x, and then find dx dt. It also has x equals 1. So before I take the derivative, I'm going to go ahead and plug in the 1 for x. And I actually meant to say when x equals 1 and y equals 1. Let me double check that that's correct. If you plug in a 1, 1 squared is 1, square root of 1 is 1, so this would equal 1. This would be 1 times 1, and a 1 plus a 1 equals a 2. Okay, now we're ready. So then take the derivative. When you take the derivative of this, we need to use the product rule. So the derivative of x squared will be 2x, and then leave the square root of y alone. Then plus, oh, right here, I forgot to do the chain rule and put the derivative of x. Let me fit that in there. This is supposed to have times the derivative of x because of the chain rule. All right, that's the first part of the product rule. Next, it's going to be leave the x squared alone and then take the derivative of the square root of y. And the derivative of square root is 1 over 2 times that square root. And then because of the chain rule, I have to take the derivative of y. And then plus, do the product rule over here. So the derivative of x will be x prime. And then leave y alone. Plus, the last part of it, leave x alone. And take the derivative of y prime. And on the right side, the derivative of 2 is 0. So now we have a bunch of numbers to plug in, like y prime equals 4. Also, x equals 1 and y equals 1. So I'm going to go ahead and plug in all of those numbers first and then simplify. So this is going to be 2 times x, and x is a 1. This is what we're looking for, so that's going to stay there, x prime. And then the square root of y means the square root of 1. Plus, so x is a 1, so that's going to be 1 squared times 1 over 2 times. and then replace the y with a 1. And then y prime, replace that with a 4. Plus x prime times y, which is 1, plus x, which is 1, times y prime, which is 4. Okay, so now if I combine like terms, this has an x prime and this has an x prime. So this is 1x prime, and then this is 2. So 2 plus 1 means there's 3 x primes. And then this number right here would be 4 divided by 2, so that's a 2, plus a 4 is a 6. And then it equals 0. The last thing to do is solve for x prime, so subtract 6 from both sides. We'll get 3x prime equals a negative 6, and then divide both sides by 3, and so x prime equals a negative 2. And for number 6, find the critical values. So that means take the derivative and set it equal to 0 and solve for x. So for the derivative, of course, we get to do the product rule. So the derivative of x is 1, and then the e function stays there, plus now the x stays there, and the derivative of the e function is the e function. And then finally do the chain rule, and the derivative of this negative x squared is a negative 2x. And then set that equal to 0. So to help out with the algebra, I'm going to say this has the e function and this has the e function, so I could factor that out. When you factor this out, all it leaves behind is a 1 plus. And over here there would be a negative 2x times an x, so that's negative 2x squared. Now technically what you're supposed to do is set each one of these equal to 0. But the thing is, the e function never equals 0, so this part has no solution. And then this will give us 2 solutions. So this really says 1 minus 2x squared, and you set it equal to 0. So I would take this negative term and move it to the right side so that on the right it becomes a positive 2x squared, and then there's only the 1 on the left. And then just 2 more steps, divide both sides by 2. So x squared equals a half. And then take the square root, and there are actually 2 answers, plus and minus, the square root of a half. And then finally, x equals, well, the square root of 1 is just 1, so on top it's basically just 1, and on the bottom it's square root of 2, and there are the critical values. And then, from the very last part of the semester, finding antiderivatives or integrating. So for this one, use u substitution, and you let u equal what's inside the parentheses. And then do the derivative. The derivative is going to be a 2x times dx. And if you look at the given problem, it has x times dx, and this has x times dx, which is good news, but this 2 is not supposed to be there. So then I could just multiply both sides by 1/2 to basically get that 2 out of the way. So it's going to be 1/2 du, and then after these cancel, it leaves x dx. And this matches this perfectly, so that means it's ready for the u substitution. This part is going to become u raised to the 7. And then this part becomes the 1/2 du. All right, now do the opposite of the power rule. So you add 1 to the exponent, which is an 8, and then divide by that number 8. So this leaves u to the 8, so for that part. And on the bottom, there's a 2 times an 8, that's 16. And now that I'm done finding the antiderivative, put a plus c. The very last step is the question had x's in it, so the answer should have x's in it. So actually the last part is replace the u with this x squared plus 5. So put in parentheses, x squared plus 5 is raised to the 8 over a 16 plus a c, and then circle it up, and it's done. And then for the last one for today, and that is another u substitution, but at the end, we'll need to plug in a 1 and a 0. So for this one, let u equal, so this x squared got substituted into the e function, so that's what I'm going to choose as the u. And then the derivative of that is 2x dx. And we're running into the exact same thing as last time. This one has x dx, this one has x dx, but there's this extra 2, so multiply both sides by 1/2. And then it's ready for the u substitution. So this part is going to become e to the u. And then replacing the x dx will be 1/2 du. And last time I put the 1/2 right here, which is perfectly fine. You could also factor out the 1/2 and put it in front. And notice that I do not put the numbers on here because these numbers are for x. That's not what u equals. So I'm going to finish the u substitution, and once I get it back to x's, I'll put the 0 and the 1 back. So there's 1/2. The antiderivative of the e function is the e function. And now that we're done with the antiderivative, also I do not put a plus c because we're going to have numbers to plug in. So the answer is going to be a number. It's not going to be a plus c. So I just need to, for 1, change it back to x's. So the u gets replaced with x squared. And now that we have x's back, then say evaluate this from 0 to 1. So that's going to be 1/2, and you could just leave the 1/2 factored out. Substitute this number first, so that's going to be 1 squared, which is just 1, so it's going to be e to the 1, minus, when you substitute this number for x, 0 squared is 0, so it's e to the 0. And then finally, to get a decimal answer for that, so there's a 1/2 that's on the outside of the parentheses, and then put second e to the 1 minus second e to the 0. And then close the parenthesis, and the final answer is 0.859. 0.859. All right, that's it.